Hi, I'm Liz Nedden. Let's have a look at some simulation experimental results. So here's our first example. So I've got this data displayed as a table. So I've got these values, these results of the events, 0, 1, 2, 3, 4, 5, 6. So these are the outcomes of my event. And I know the probability of each of those events occurring. So the chance of getting a 0 is 0.1, and so on. So let's have a look at our questions. What is the probability of getting a value more than 5? So what values could be more than 5? Well, the only event that can be more than 5, the outcome, is 6. So the chance of getting a 6 is 0.25. Question number 2. What's the probability of getting a value of at most 3? So at most, that means less than or equal to 3. So less than or equal to 3 could be 2 or 1 or 0. So the probability of getting that, I need to add together those three probabilities there, and that will give us an answer of 0.3. Question number 3 there. What's the probability of getting a value between 3 and 6? So the probability of, I want to write that as 3 less than x less than 6. So that's between 3 and 6. And when I come to do that, what numbers are between 3 and 6? 4 and 5. So I want to combine together the probabilities for 4 and 5. So that's going to give me a solution of 0.25. Let's have a look at a second example. So here are our results. So this is from 400 students who have done a particular achievement standard, and these are their results. So what I want to do is I want to work out these probabilities. So not achieved had a frequency of 96. As a probability, that would be 96 out of 400, which I can leave as a fraction like that, or I can turn into a decimal of 0.24. So either of those is correct. Achieved, well, there are 188 students out of the 400 who got achieved. So 188 out of 400 as a decimal would be 0.47. Merit, well, there were 92 out of the 400 that got a merit, so that gives us a probability of 0.23. And lastly, excellence is 24 out of 400, and that gives us a probability of 0.06. So that's the first thing. If I've got count data, I need to turn it into probabilities. If I now take that data and want to draw that as a graphical representation, there are two different kinds of graphs that I can draw. I can draw a frequency graph, and that's where we have our frequency on this axis here. So this is when I would go, now my frequency is this one here, so that the highest is 188. So I'm going to have a maximum frequency of 100, 200, there. Whereas the other type of graph I could do is a relative frequency graph. So that's when this axis here is now the probabilities as decimals usually. So that's my relative frequency graph. So we can say our highest probability there is 0.47. So let's go up to 0.5. Half of that is 0.25. And 0.125 and 0.375. So that's the differences. I'm going to draw each of these two graphs. The shape and everything will be very similar. In fact, the shape will be the same. So what I've got across my x-axis is my grades N, A, M, and E. So that's the same on both types of graphs. And now I just want to draw them as a bar graph. So the first one, not achieved, has a frequency of 96. So I'm going to draw a bar that's about 96, and as a decimal probability that would be 0.24, so I would have that coming up to just under there. Then I would draw my achieved, so that's got a frequency of 188, so I'm going to draw this going up to 188, around about there. Sorry for my lovely not straight lines. And my probability that is 0.47, so I'd go up to just under 0.5 there and draw a bar. My merit, so that's got a frequency of 92, so we're going to go up to about there. Or it has a relative frequency or probability of 0.23, so it's about there. And excellence, it's a frequency of 24, so that's just going to be a little box down there, or a frequency of 0.06, so again just a little box down there. So two graphs using the data in different ways. One is a count, one is a probability, but they're both representing the same thing. Thanks very much for watching.